Here, in the last part of chapter 3, we will observe other type of equations. So here we will have a look at the radical absolute value equations and substitution. A radical equation is an equation that contains the unknown variable underneath the radical sign. So if you see anywhere the radical sign in the equation, it means it's radical. Easy. And as you remember, radicals are only defined for positive real values and 0. So 2x plus 1, it's either positive or equals to 0. In order to solve it, we want to get rid of this radical sign. And one way to do it is to square left and right side of the equation. But as you remember, raising to the power of a even number, it's not an equivalent transformation. So these apparent solutions need to be checked by substituting them into the original equation. So let's solve this example here that we have. So the root is isolated, and because it's isolated on the left side, both sides can be squared in order to eliminate the root. So in order to get rid of radical sign, we square both sides. For here, we get rid of this, so we will have 2x plus 1. And here we can use binomial formula and expand it. So it will be 34x plus 289. And then we can move everything to the one side. We can collect and simplify everything on one side. First of all, if you remember, we can change this side here and this side here. So x squared minus 34x plus 289. And then we can minus 2x plus 1 from both sides. And then we will get x squared minus 34x minus 2x plus 289 minus 1 equals to 0, because if we subtract this from this, we'll get 0. If we simplify it by combining these elements, we'll get the following: x squared minus 36x plus 288 equals to 0. So in the end, we will have this quadratic equation. You can pause video now and try to solve it with PQ formula or any other method that we used before, and then try to solve it yourself. Now we can continue. To save time, I will tell you the result. x1 will be 12 and x2 will be 24. So on the first side, we would think that, okay, these are our solutions. But as I told you before, powering both sides of the equation, it's not equivalent transformation. So we will not always get equivalent equation in the end. So that's why we need to check it. So what we do, we check if these two answers will satisfy the original equation. So original equation, which was 2x plus 1 equals to x minus 17. So we need to check them. So we put them back. So for example, we want to check for x1. Checking for x1, we will end up 2 multiplied to 12 plus 1 equals to 12 minus 17. So here we will have 25, and here we will have minus 5. So this is untrue statement. Square root of 25 is 5. Hence, this is not valid. This answer is not valid. So let's check it for x2, which is 24. So we get 2 multiplied to 24 plus 1 equals to 24 minus 17. And this will give us square root of 49 equal to 7. And this one gives us 7. And hence our solution 24 satisfies the original equation. Also, which is important here, if you remember, we had 2x plus 1 here, and it means that x is bigger than minus half. So x must also lie in the domain of the solution set. The solution set also must satisfy this domain here. Since 24 satisfies the domain and plus we checked in the original equation and it gives us true statement, our solution set will be 24. The next type of equation that we're gonna cover today are absolute value equations. So an equation will be called an absolute value equation if the absolute value of a known appears in one or more terms. So equation is called absolute value equation if absolute value appears anywhere in the equation. For example, x plus 5 equals to 7. So if you remember the absolute value, we write it in those vertical bars. And it is positive if x is bigger and equal to 0, and negative x if x is smaller than 0. If you remember, this was the definition of an absolute value term. So if we look at this equation here, we have x plus 5 here, and from here we can have two cases, because this is an absolute value for two cases. If x plus 5 is bigger or equal to 0, or if x plus 5 is smaller than 0. The idea here is both of these two terms, they will have the same absolute value. That's why we have to look at them separately. So for every absolute value, you have to look at these two separate cases. So the first case will be here. So if we will just think about it, this is our plus and this is minus. This one here is our plus and this is a minus. So we have to look at two different cases. In the first case, if x plus 5 is positive, then we can solve this equation as x plus 5 equals to 7. Then we will find out that normally it will be 2, right? And here, if x plus 5 is smaller than 0, then it will be minus x plus 5 equals to 7. In this case, we just open the brackets, minus x minus 5 equals to 7. Then we can add to both sides. 5 will be minus x equals to 12. And finally, x will be equal to minus 12. So, as you can see here, our solution set will include both these numbers, 2 and minus 12. So again, for the absolute value equations, you have to look at two cases where the term that is in absolute value is negative or positive, bigger or equal to 0, or same term is smaller than 0. Okay, let's move to the next topic. And again, the good news, it will be the final topic for today. So, substitution. So this is not particularly the type of equation. It's again one of the ways we can solve the equations which are not quadratic, for example, but have a higher power. So sometimes to reduce complicated equations to a simpler form, and we can just do a substitution. It means that we replace or we swap expressions. This method can be extremely useful, in particular when the powers of one term are twice as large and in other terms, like in certain big quadratic equations. So for example, x to the power of 4 minus 13 x squared plus 36 equals to 0. So this is not quadratic equation, but as you may see here, you can see that these two terms, they look very familiar as our quadratic equation, but the only thing that they're 2 times bigger than the quadratic equation. So what we can do here, we just use our substitution method, where we assign x squared is equals to u. And then we just rewrite, taking in mind that if x squared is u, then x to the power of 4 will be u squared minus 13u plus 36 equals to 0. So now this one looks much better. This is quadratic equation that we can solve with PQ formula. You can pause and try to solve this equation yourself using PQ formula, and then come back to check the answer together with me. So let's continue. I hope you already solved it yourself, and now we can just check the results. We can solve it with PQ formula. If you remember, we can find our roots. It will be 13 divided by 2 plus minus, and so it's minus 13 divided by 2 and squared minus 36. All right, and discriminant is definitely non-negative, so it means that we have 2 solutions here, and u plus will be 9 and u minus will be 4. So here we have 2 solutions, and because we found these 2 solutions, we can now take these solutions of u and put them here and find x squared. X squared will be, so let's take for the 9, will be equal to 9. So there's 2 numbers which could give us 9. It's 3 and minus 3. So we will have x1 equals to 3 and x2 to minus 3. So we have 2 roots here. And the next one, the same for the x squared equals to 4. So there's also 2 numbers that can result to 4. If we square them, it's 2 and minus 2. So it's x3 will be equal to 2 and x4 will be equal to minus 2. And the solution set here will be, so we can go from the negative numbers, minus 3, minus 2, 2, and 3. So we have 4 roots here. Important thing here, every time you have roots, you have to check them just to be safe and just to make sure you solve the equation properly. You should put your roots here into the main equation and see if it holds. For example, let's take minus 3 to the power of 4. Minus 3 to the power of 4 will be 81. Minus 13 multiplied to 9 plus 36. So if we calculate it in mind or using calculator, it will equal to 0. It means that this is a correct root of equation. So then you can check all those guys, and if you made a mistake somewhere, or if you made some transformations which are not the equivalence transformation, so the last thing you do after you solve the equations, you have to check the roots. Okay, thank you for your time. Today we had a very long session about equations. We looked at different types of equations and different ways to solve them. And I hope it was useful for you. And I'm going to see you in the next chapter 4, where we will closely look to inequalities.